Yeah, comes on everyone. Let's start off. So last thing we did was kinetic energy. Next thing. Work energy theorem. Now we know the work done is integral f bar dot dr. This can be written as mass into acceleration dot dr. This is nothing but v dv by dr. That is m into integral v dv. So when you integrate this from u to v, this will be half m v square minus half m u square. This is work there. So work done by all forces is change in kinetic energy. Half mv final square minus half mv initial square. Work done by internal conservative forces, which we have done last time. Is negative of potential energy. Be careful. Don't mix up both of them. These are the kind of theoretical questions they ask. All forces, matlab everything included. This is only internal conservative forces is minus delta U. Is this clear, everyone? Again, I didn't use anything hi-fi here. I know work ka formula. I said F is MA and then I just integrated this. The work energy theorem, if you actually see, it came from kinematics only. Work ka definition and then kinematics.
Sir, sir, like, why is it work for internal? I thought, sir, it should be like conservative force only. Like, for example, gravity. So, sir, the work done by gravity is the negative of the change in
So
potential gravity.
definition is, what is your system there? What is the
Sir,
system?
the box that's falling.
So only body is a system, then the earth is an external force. When you say potential energy, it is an energy because of interaction between two systems.
Okay, sir. Understood, sir.
No? Potential energy is because it's coming due to interaction between two systems. So it is always internal. The moment you say body is only system, then don't define potential energy. Then it becomes an external force that will go into this category. All clear with this? Clear na everyone? Then now this work done by all forces, which you wrote as change in kinetic energy, you can classify this all forces into two parts. You can take this thing as work done by internal conservative forces and work done by the external forces. Now, when I say internal conservative force, keep it simple. Spring forces, gravitational, electrostatic. That's it. These are the three things which we see. Spring forces, gravitational forces, electrostatic. These is what we take as conservative here. Here, when I say external forces, friction, air resistance, or any other force that you apply from outside. So this can be written in work done by all forces is work done by internal conservative plus work done by external forces is change in kinetic energy. But I already know this is minus delta U. The work done by external is change in kinetic energy. So send it that side. We get work done by external is change in kinetic energy plus change in potential energy. So there are three things, huh? Work done by all forces, internal conservative forces, external forces. We're talking about three different things. Have a look at this. Next page, I'll write in more detail. Clear, everyone? Now, if I write this, the work done by external forces is change in potential plus change in kinetic. So potential energy plus kinetic energy, this is called total mechanical energy. So this can be written as work done by external forces is change in total mechanical energy or total energy, they'll simply say. This is your third one. I can write both of them together. So be careful. This was a theoretical question. They said which of the following statements are right? They asked like this: what is work done by all forces, work done by internal conservative forces, and work done by external forces? So work done by all forces is change in kinetic energy. Work done by internal conservative forces is change in potential energy with a minus sign. Work done by external forces is change in total mechanical energy. They all will look kind of same, but be careful. What is what you should know. That would be an easy question, but you can expect something like that in mains orbit. So work done by external forces can be written as energy final minus energy initial. So the same thing, so I can also write like this. Energy final, this is more intuitive. Whatever energy initially you had plus whatever extra work I did, that must be final, isn't it? If you have 50 rupees and if I give you 20 rupees, totally should have 70, isn't it? So whatever you have initially plus whatever I give you must be the final. That's an intuitive way of writing, but it's the same thing. If work done by external force is 0, then E initial becomes equal to E final. This is called law of conservation of energy. So if you see, work energy theorem is more powerful. Law of conservation of energy works only when external forces are 0. Work energy theorem works every time. Law of conservation of energy. This can be also written as change in potential energy plus change in kinetic energy is 0 if work done by external force is 0. So therefore, I can write minus delta PE is plus delta KE. So this means school may also studied this. Loss in potential energy is gain in kinetic energy, or vice versa. Loss in kinetic energy is gain in potential energy. It is the same thing. We're just manipulating writing left and right. So there are multiple ways you can write this thing. So if there is a work done by external force, use work energy theorem. If the work done by external force is zero, it becomes called law of conservation of energy. So work energy theorem is a more powerful one. Law of conservation of energy is a subset of it. There, have a look at this. So there are multiple ways you can write. You can say E initial is E final. You can say loss in PE is gain in KE, or gain in KPE is loss in PE. It's the same thing you're talking. You're just mixing and matching the words. Is this clear, everyone? Turning the page. Can I go ahead? Arnav, Ahana, Arush, clear? Adi, Vihan, clear? Sharman, Surya. This is an important one. What if you're standing in a non-inertial frame? If you're standing in a non-inertial frame, then the formula becomes work done by external plus work done by pseudo force. Pseudo force also has to be included as an external force. Is change in kinetic energy plus change in potential energy. So you can use work energy theorem even in non-inertial frame, but include the pseudo force also. It will work. Like I said, pseudo force behaves like a force for all as far as solving is considered. It doesn't exist, but it will work for problems. So how do you solve these questions? Steps to solve. Step 1, choose your system. And define your initial and final state. Define your initial and final state. So ask yourself, what is your initial situation? What is the final thing? Question may normally they'll ask you, right? Velocity is given, find the maximum height, find the maximum compression. So that maximum he is asking is your final state. Second, choose your reference line. Choose your reference. Calculate gravitational potential energy, spring potential energy, kinetic energy at initial and final. Third, find work done by external and pseudo forces. Again, pseudo force depends on the frame. If you want to solve a non-inertial frame, you will see later on. Sometimes it is convenient. So they include pseudo force. Work done by external and pseudo forces.
So what is SPE?
Super potential energy. Spring potential energy, right? Fourth thing, use work energy theorem. Spring potential energy. लिख लेता हूँ. This is spring. Gravity. Then use work energy theorem. There, people. This is your second algo here. The first one was your NLM ka thing. Draw a FPD, write equation, solve and all. This is the steps we use to solve all work energy problems. So end mein na, after centromass collisions, I'll teach you, like, we start a problem like this. You have a problem. Step 1, we have to choose. Should I use NLM? Should I use conservations? If NLM, do this, this, this. If it is work, this, do this, this, this. So we have all mechanics problems that can be classified into one of these categories. So when you see a question, you'll get an idea. Okay, should I use FBD or should I use energy? We will see that, but let's see a few questions. There, that's your work energy theorem there. This was the last question, 15. Look at the steps. Ask me if you're confused with the steps. Clear? Go ahead. Let's start with something easy. So we have a surface like this. This height is 20 meters. This height is 5 meters. This height is 10 meters. Here we have a block here, 2 kg. This is a smooth surface. The block is released from rest. So what will happen? The block will slide, will come like this. This angle here is 30 degrees. The block will fly here and fall somewhere here. This is your range. So let's call this point A, let's call this point B, let's call this point C. Find the speed of block at C and the range. Let's get this. And when it hits the ground, let this be angle alpha. At the speed of block C, find range and alpha. Alpha is the angle when it hits the ground. So block slides and flies away from point C. Hmm. Take a minute, then I'll show you. Find the speed at C. Get the range also. Once you get the speed, it becomes a kinematics question. Did I help you with one? Let me hear the first one. Speed 200 बहुत ज़्यादा है, you're going to kill people there. Let's see. Yeah. So step 1, choose your system. That is the block M. Right? Define your initial and final state. So I'm talking about A and C first. So this is my state 1. This is my state 2. What about B? I don't care about B, right? You want the speed at C. So why do I care about B? It doesn't matter. You're getting it. So B is actually useless in this question. That is just given there. State 1, state 2. Define your reference line. I will choose the ground as reference line. You can take actually anyone as reference. You could have taken this as reference. Then calculate your potential energy. Initially, gravitational potential energy, mg20. Kinetic energy, 0. It is at rest. Spring energy, there is no spring. So I will not write. State 2, gravitational potential energy, it is at a height of 10. So mg10. Kinetic energy, that's what we need to find. Let the speed be v here. Half mv square. Are there any external force on the system? When the block is sliding from A to C, are there any external forces? Again, remember, when I say external forces, gravity is an internal force that is already included. Other than gravity, are there any other forces on the system? There is normal reaction. There is a normal reaction, but work done by normal reaction is zero because it is always perpendicular. So be careful, huh? They'll ask you a question like this. If the work done is zero, does that mean force is zero? Not necessary. So normal reaction is perpendicular to displacement. So therefore, work done by external forces is zero. Therefore, energy is conserved. You need to first prove that energy can be conserved. Blindly don't conserve energy every time. Therefore, initial energy is equal to final energy. So energy in state 1 is equal to energy in state 2. So initial energy is mg20, mg10 plus half mv square. M cancels. We will get 100, 200 ka root is v. That is your speed, 10 root 2. Easy, everyone?
Sir, isn't normal an internal force?
नहीं, what is your system यहाँ पे पुरोजा? यहाँ पे मेरा system is earth and the block. So gravity is an internal force, right? That's what we are saying. Normal has nothing to do with gravity. ठीक है? So remember everyone, the moment you say gravitational potential energy means you indirectly have assumed the earth is a part of the system. The gravitational force is an internal force. The moment you say spring potential energy, spring force वापस लेना नहीं है. I hope you're getting that point. The moment you use gravitational potential energy, mg is already taken care of. Any doubts till this page? Clear? The next part. Now it has become a projectile question. So this is like this. This angle is 30 degrees. So be careful. This is 30. So this is actually 60. I hope you took the angles right. If you have taken 30, you goofed up. This is 30. That is 60. Now this is flying and falling on the ground. And this height is 10 meters. This is a kinematics question. You know what to do. What is this thing? Time of flight minus 10. We are using the formula Sy is equal to uyt plus half ayt square. Now, once you got the velocity, question is over. It's not work per energy anymore. So it's minus 10. Uy will be 10 root 2 sine 60. Now it's bad. Minus half gt square. You can leave it here. Calculate this, you'll get the time. Range will be horizontal velocity. 10 root 2 cos 60 into time. How to find this alpha? At this instant, this velocity will be v dash. Again, I can use conservation of energy. So here, if the speed is v dash, this is my state 3. So state 3, gravitational potential energy, 0. Kinetic energy, half mv dash square. Then I will get energy in state 1 is equal to energy in state 3. You can conserve energy everywhere. 1, 2, 3, all are equal. This would be 20 mg is equal to half mv dash square. This v dash will be 20 meters per second. So when you hit the ground, your speed is 20 meters per second. Why do we need this? Because you want to find alpha. We know the actual projection u cos theta is equal to v dash cos alpha. So u is 10 root 2. This is cos 60. V dash is 20 and this is cos alpha. Or you can use tan alpha is equal to u sin theta minus gt by u cos theta. That also works, but that becomes cumbersome. There, so cos alpha will be 10, that is 1 by 2 root 2. So if you have to ask you this question in the exam, I'll ask you find alpha directly. Then you have to find v here, then you have to find v dash here, and then we have to use v cos 60 is equal to v dash cos alpha. Please check. First of all, everyone is clear? State 1, state 2, state 3? You can define anything as any state you want. It doesn't matter. Any doubts in this? Look at this page. Any doubts on this? Clear? Can I go ahead? Clear, no? Surya, Nikhil, Arnav, Abhinav, clear with this? Ansh? What if I choose block and the ground as a system? Choose, na? Choose. Who is stopping you? Then what will you do with it? Your potential energy depends on gravity, not depends on the ground. You're taking the whole Earth as a system, only for the gravity purpose. Choose Earth as a ground as a system, nothing happens. The ground is anyway not moving. Next one. So we have a building of height h. You projected here with an speed of 20 meters per second at an angle of 60 degrees. This thing goes up and then falls on the building here at an angle of 30 degrees. Find height of the building. Initial speed is given, final angle is given, initial angle is given. How do you find the height of the building? Any ideas? 40 by 3. 40 by 3. Okay, we have 340 by 3s. So how do we start this? I'm combining kinematics with work per energy. So here, let the speed be v. I don't know. Define your state 1, state 1, state 2. Define your reference line. I'll choose the ground as reference. Gravitational potential energy, 0. Kinetic energy, half mv square. Gravitational potential energy, mgh. Kinetic energy, half mv square. So first thing, from kinematics, we know u cos theta is equal to v cos alpha. Horizontal velocity always remains constant. So this is 20, cos 60 is half, v I don't know, and this is cos 30 is root 3 by 2. So from here I got v is equal to 20 by root 3. Then since there are no external forces here, gravity is internal. E1 is equal to E2. Potential energy is 0. Half m 400 is equal to m, g is 10, height h plus half m 20 by this, so 400 by 3. M cancels everywhere. This is 200. This is 10h. This is 200 by 3. 10 cancels everywhere. 20 minus 20 by 3. 40 by 3. Check. Easy. So the thing is that you should know that u cos theta is v cos alpha. Making sense? This is what I was saying. Everything you learned before will keep popping up. So if you don't know your basic kinematics, you will have issues. Next one. Any doubts? But that is the biggest clue, Ray. You know, when this thing lands somewhere and they give the final angle, that is the biggest clue, boss. You have to use u cos theta as v cos alpha. Next one. We have a pendulum here. Mass m, length L, angle theta, gravity is there. This is released from rest. So this guy is going to swing. So the first question, find the speed and the tension at the lowest position. This is a string. Second thing, if magnitude of initial acceleration initially and at the lowest position is same, and the lowest position is same, find theta. Let's get this. Anyone didn't get the question, please ask. First one will come in terms of theta, m and stuff. First find the speed at the lowest position, then find the tension at the lowest position. Try. Got 2 minutes for the first part. Okay, get the tension also. Speed is root 2 GL1 minus cos theta. Yeah, that is right. Most of you did get that. Root. Hi, Shana, you got the tension right also. Get the B part. Daksha, that's not the answer. Ansh, I think you goofed up. Dimensions match नहीं हो रहे अंश. L extra आ गया तुझे देखो. Arush, speed is right. Go ahead with the tension. अरे हंस उसको कुछ थोड़ा ऐड करके करना फाइनल आंसर. You want to just leave it like that. Let's see the speed part. Step 1. Define your initial state. Finally, when it comes here to the lowest point, it'll have some speed v. This is my state 2. So from here, if you look at this difference here, that is L. This will be L cos theta. That means this difference will be L into 1 minus cos theta. So I will take the ground as reference. This line is reference. So here, potential energy, 0. Kinetic energy, half mv square. You can actually simply say loss in PE is gain in kinetic energy henceforth. I'll stop writing like this later on, but okay, for a few times, let's write it down. So here the potential energy is mg into height, which is L into 1 minus cos theta. Initially, you're starting from rest. So kinetic energy, 0. Are there any external forces on the system? Think and tell me, don't shake your head. Are there any external forces on the system? Yes, there is a tension.
Gravity.
Gravity is always internal if you take potential. The moment you use the word gravitational potential energy, you're including it in internal. Tension is the external force. Isn't it? Tension string is there now. Work done by tension is there, but it is 0. Why? Tension is perpendicular to displacement. I know it won't affect the problem, but knowing it is important. So blindly, if you just assume every time energy conservation, there will be a problem where you'll get stuck and then you'll think why you're not getting the answer. So tension is there, but it is not doing work. Energy in state 1 is equal to energy in state 2. Always remember, Arush, like the moment you say gravitational potential energy, the moment you say gravitation, it is included. Okay? So initial energy mg L 1 minus cos theta is equal to half mv square. Therefore, V is equal to root over 2gl1 minus cos theta. What the second thing I asked you? Find the tension. Now tell me one thing. The moment I ask you find the tension, what am I asking you to find? Force, right? You tell me in which chapter did you learn how to find forces? NLM. And what you do first thing in NLM? Draw an FBD. So at the lowest position FBD tension, mg. And remember, you're going in a circle. Circular motion is also there. So since you're going in a circle, you will also have a centripetal acceleration AC, which is V square by L. Therefore, the forces will be tension minus mg is mass into acceleration. You can take centrifugal force also. Therefore, tension will be mg plus mv square by L, which is 2gl1 minus cos theta. So the tension will end up to be 3 mg minus 2 mg cos theta. I can just take out mg common. 3 minus 2 cos theta. Is that clear, everyone? So first we have to use work energy theorem to get velocity and then draw an FBD to get the tension. But while drawing in FBD, be careful, it is going in a circle. So there will be a centripetal acceleration. There, your work power energy, NLM, FBDs, everything will pop up again. Question still not over. The second one is a good one. If the magnitude of initial acceleration and the lowest position acceleration is same, then what must be theta? Any doubts on this page? Please ask me. Confused with the energy? How did it get velocity? Why did it take tension like that? What is acceleration? Anything that you didn't understand, please ask.
Sir, if we use the work done by all forces equal to kinetic energy, if we use that, then what?
Then mg भी include करना पड़ेगा. Then you have to take work done by mg also in that external force. Now mg is an external force, na?
Sir, in that, what will be the reference?
There is no why do you need to reference? There is no potential energy only. Work done by all forces change in kinetic energy. There is no potential energy का term there, so there is no reference only. Then उसमें क्या होगा? देखो, mg is pulling down ना? Then you have to include work done by gravity also, which is mg into L into 1 minus cos theta. That will be equal to half mv square. You'll get the same answer though. ठीक है? Second part, everyone. What about this guy? Try, I'll give you a minute. When you release it, you will have some acceleration. When it reaches the lowest position, it has some acceleration. And he's saying these magnitudes are equal. Then what is theta? Sin theta plus 2 cos theta is 2. Okay, I know that. Simplification, you can leave it like that. What is the catch here for the second part? See. So when you're releasing it from rest here, what are the forces? Tension, mg cos theta, mg sin theta. What are the accelerations? A centripetal is 0. Why? Since velocity is 0, initially you're at rest. But there's an A tangential. So mg sin theta is equal to ma tangential. This is a non-uniform circular motion. So initially there is no centripetal acceleration because you're starting from rest, but there is a tangential acceleration. The same guy, when it comes to the lowest position, tension mg, and you're going in a circle, there is an A centripetal, which is v square by r. A tangential is 0 because there are no horizontal forces. So when the moment you release, there's only tangential acceleration. At the lowest position, there is only centripetal acceleration. You are saying these two are equal. And how much is v square? Just now we calculated 2g L1 minus cos theta. So v square by L. So 2g 1 minus cos theta. Now you're saying these two are equal. So you're saying A tangential is equal to A centripetal here. So g sin theta is 2g 1 minus cos theta. G will cancel. You'll get sin theta. I can simplify this further. Right? Sin theta can be written as 2 into 1 minus cos theta. Sin theta can be written as 2 sin theta by 2 cos theta by 2. And 1 minus cos theta can be written as 2 sin square theta by 2. 1, 2, 1 sin theta by 2 will cancel. Then you end up with tan theta by 2 is equal to half. Therefore, theta will be 2 times tan inverse half. Right, Niharika, you got that. That is how the options will be in the exam. So you can simplify that. Is this clear, everyone? It's a pretty good one. Check out the steps. So you need to find the velocity to find the A centripetal. Tangential to aa jayega because A tangential initially there's nothing there. Is this clear, everyone? Let's see one more. Turn the page. This is fixed here. This is a mass M, length L. This is string is released from horizontal position. So when you do this, what will happen? This will start swinging. So after some time, it will come somewhere here, theta. So here it is released from rest. So when you do this, so this thing must have gained some speed v here. So first question, find speed A centripetal, A tangential when it rotates by an angle theta. टेंशन भी कैलकुलेट कर लेना टेंशन and it rotates by theta. Gravity is there anyway. Second question, find theta when A net is horizontal. Find theta when net acceleration is horizontal. So A centripetal and A tangential ka resultant should be horizontal. Let's get this. Hope the question is clear. First part is still fine. Let's see. Let's see the speed. Speed is easy. So this is your state 1, this is your state 2. So if you drop a perpendicular here, that is L. So this length is L sine theta. So loss in potential energy is gain in kinetic energy because there are no other works done, tension doesn't do work. So how much potential energy did you lose? mgl sine theta. Initially your velocity was 0. So how much kinetic energy did you gain? Half mv square. Is this making sense, everyone? This is another way of writing the same thing. You can define state 1, state 2, write everything. This saves you time. You can simply say whatever potential energy was lost must have converted into kinetic energy. There's no one else here. There we got the velocity v is equal to root over 2gl sine theta. Fair enough. Surya, clear with this? Go wash your face and come. Looks like you're sleepy. So this is theta here. This is your mass m. If you draw the free body diagram, this will be tension. This is mg. This would be theta. So this is 90 minus theta actually. So this component would be mg sine theta. This would be mg cos theta. Those are mg components. Now remember you're going in a circle. So you have a centripetal and you have a tangential. So a centripetal is v square by L, which is 2g sine theta. And mg cos theta is the one who is providing a tangential. So that is ma tangential. So a tangential is g cos theta. What about tension? Tension is T minus mg sine theta is equal to mass into centripetal acceleration. That would be mg sine theta plus 2 mg sine theta. So tension at any instant is 3 mg sine theta. Check. Anyone not clear with the steps, please ask. The theme is always the same. Once you get the speed, you have to draw an FBD. The moment I ask you find tension, find normal reaction, you don't have an option other than drawing FBD. You cannot calculate tension and accelerations using work energy theorem. So you can be sure the moment they ask you find tension and acceleration, FBD comes into the picture. How to get the angle? I give you all the data. So he's saying A centripetal and A tangential ka resultant is horizontal. Try, I'll give you a minute. So this is theta. So at this instant, you have A centripetal this way, A tangential this way, and now you're saying A net is this way. That is theta, this is theta, and this is 90 minus theta. That means indirectly you're telling in the vertical direction, the components are canceling out. This would be A centripetal sine theta must be canceling out A tangential cos theta. Since A net is horizontal, vertical component must be 0. This turns out to be a centripetal sine theta is a tangential cos theta, but a centripetal is 2g sine theta, so and a tangential is g cos theta. We get tan theta is 1 by root 2. Check. Clear with this? You're seeing now how questions are like, it's literally everything is popping up. Energy, forces, tension, circular motion, everything is coming. Any doubts on this? Next one.
Sir, 1 minute.
Hmm. Clear na, Arna? Adi, Surya, clear with this? So just going ahead. Let's say we have a rod here. This is hinged, meaning basically it is fixed. We have a mass m. We have a mass 2m. This is a light rod. It's not a string, it's a rod. But it has no mass. It is a light rod. This length is L. This length is also L. This is released from rest. So they will swing like this. So a light rod of length 12 with mass m and 2m are attached as shown. Find the speed of m and 2m in tension in the rod at the lowest position. Question is clear, right? Read the question. Tension in the rod. Find everywhere. Nothing is mentioned. You find everywhere. I know why there is a query. There is a trap. First find the speeds, na? Tension you can see later. Get the speeds first. Just give it a try and get some water and come. Anyone got the speeds? Let's see. First of all, I hope you didn't fall into the trap. Did you guys think, what do you think about the speeds? What is same for both the particles? Omega. Puruja got it right. It is not the speed. Think about it, God, it's a light rod. So if you look at the diagram here, think about your fan. Does every point on the fan have same speed? So at the lowest point here, both have same omega. The rotation angle is same. So that means if this guy is rotating with L omega, this guy is going with 2L omega. So if this speed is V, this speed is 2V. Both the particles don't have same speed. Is that making sense? Look at your fan ka blade. The points inside are going slower and the fan ka tip is going faster. The most common mistake here, what people do, they think both the speeds are same. If both the speeds are same, the rod will be like this. Isn't it? Then loss in potential energy is gain in kinetic energy. So loss in PE is gain in KE. So how much did this guy fall down? This guy fell by distance L. This guy fell by distance 2L. So that would be mgl plus 2mg2l. Kinetic energy half mv square plus half 2m 2v square. So this is 5 mgl and that is 9 mv square by 2. So v will be root over 10 gl by 9. This is your speed, everyone. Check. Both the bodies are losing different amount of potential energies. Both the bodies are gaining different velocities. You have to take the whole thing as one system. So the rod is redistributing the energy between them. The biggest mistake people do here is they think the velocities are same. That is your first trap. And both the things are not losing same potential energy. Have a look at this. This itself is a question. Everything that I'm asking is proper advanced questions. Huh? Literally, this one is an advanced one. This is an advanced one. So how to find the tension? Try. I'll give you a minute more. Like I said, the moment I ask you tension, you have to draw an FBD. So actually, omega aa jayega yahan se. So omega is V by L. So I can find everything. So this is velocity of M. Velocity of 2m will be 2 times root 10 hg and gl by 9. Omega is root 10g by 9l. That is the omega of the rod at the lowest position. Please check. Now find the tension in the rod. Yeah, you cannot take M1, M2 separate. There is a rod catching them both, right? So there is an external force. The rod is doing some work which I can't calculate separately, so I have to include them. How to find the tension, everyone? See, again, we have an issue here. The rod does not have same tension everywhere. So here we have M and here we have 2M. This is going in a circle, this is going in a circle. So FBD, this would be tension T2, this would be 2 mg. It's going in a circle, centripetal acceleration is omega square 2L. This guy, tension T1, tension T2, your own weight mg, you're going in a circle, centripetal acceleration omega square L. This becomes like the circular motion ka question. Then this will be T2 minus 2 mg is m omega square 2L. From here you'll get T2 ka value. Omega ka value already know, you can substitute. And for that guy, it'll be T1 minus T2 minus mg is m omega square L. So T1 will be T2, which is 3 mg plus 3m omega square L. That's how you find them. So the rod will have two different tensions. So this rod will have one tension, this rod will have another tension. The upper part and the middle part will have two different tensions. Doesn't this question look like this? This question, no? Each section of the rod will have different tension because of the masses in the middle. So here omega is given, there you have to find omega. This is a good one.
Sir, in the first line, won't it be 2m omega square 2l?
2m omega square 2l. सही बोल रहे हो. Clear? Any doubts on this? Next one. Next one. We have a pulley here. We have a block here. Let's say block of 2m. Here we have a block of mass m. Initially this angle is 30 degrees. This is A, somewhere here is B. So this block starts sliding and it becomes like this. This angle becomes 60 degrees. Anyone remembers this? This distance is 2 meters. Anyone remembers this question? I think we did this in foundation, if you remember. We did this in foundation. ठीक है. There's somewhere. So block is released from rest. The ground is smooth. And when released, it slides to B. Find the velocity of the blocks when it reaches B. Is the question clear? Initially 2m, m is there, initial angle is 30. When you lift it, because of that m there, this block starts sliding on the floor. It can't lift off because 2mg is greater than m. So when it reaches the 60 degrees here, this thing will have some speed and this will have speed downward. Find the speed of 2m and m. Next class, we will touch the springs. Today, we are not touching springs. First of all, can you find how much did this block fell down? Can you find this first? Because loss in potential energy is gain in kinetic energy, right? 2m is not losing potential energy. The only one is losing energy is m. So you need to find how much distance this block is falling. So that mgx will be kinetic energy of both the blocks. And do you think both the blocks have same speed? This will have v1, this will have v2. Speeds won't be same. So the loss in potential energy mgx is half 2m v1 square plus half m v2 square. You need to find relation between v1 and v2. You have to find what is that x. Constraints, everyone. Try. I'll give you a minute more. First, find that x. How much did that block m, comes down when it goes from A to B? A to B ka length is 2 meters. (40√3). This is the speed of m. Kya? Okay. What did you take relation between v1 v2? Hope you have not taken both same speeds. You took different, no? So relation would be v1 will be v2 by 2, na? Did you take that? Power method, right? T1 v1 bar is plus T2 v2 bar is 0. So you will get v1 must be v2 by 2. Did anyone get the height? How much did the block fall down? See. You tell me. Let's say if this is A, let's call this C. Example, okay? If this length is 5 meter, this length is 3 meter, what happened to the remaining 2 meters? Someone must have taken it. Who must have taken it? The block, right? Is that making sense? If this was 5 and this was 3, baki 2 meter kahan pe gaya? The 2 meter must have come down here. Is that making sense? So the distance moved by the block is nothing but the difference in length of the string from the A to the pulley. So this distance here, let's call it x. Since the length of the string is constant, distance moved by the block is the difference in length of the string from block to pulley. That means x is nothing but AC minus BC. How much is AC and BC? Look at this thing. This is an excellent isosceles triangle. This is 30 degrees. This is 60 degrees. So this is 120 degrees. So this is also 30 degrees. This is A, C, and B. So if this was 2 meters, this was also 2 meters. From here, drop a perpendicular, you'll get 60 degrees. This will be 2 sine 60, 2 sine 60. That will be 2 root 3 minus 2. That will be 2 into root 3 minus 1. That is the distance the block M comes down. It's not 2 meters, everyone. Please check this part. So when the block 2M goes from A to B, this block M comes down by 2 into root 3 minus 1. Yes. What happened? Today's class is a little heavy. People are tired. Then, so once we got this, at this instant, let the speed be v1, let the speed be v2. Tension in the string is T, tension in the string is T. We know from power method, T1 bar dot V1 bar plus T2 bar dot V2 bar is 0. So we have minus T V1 plus T V2 cos 60 is 0. So V1 is V2 by 2. Both have don't same velocity. The loss in potential energy is gain in kinetic energy. Loss in potential energy, only M block is going mg 2 root 3 minus 1. Gain in kinetic energy half mv1 square plus half 2m v2 square. M cancels everywhere. This is 20 root 3 minus 1. This is v1 square by 2 plus v2 square. v2 is 2v1, so that is 4v1 square. That is 9v1 square by 2 is 20 root 3 minus 1. So v1 is 40 by 9 root 3 minus 1 ka root. Check. So first thing is figuring out length of the string is constant. From there you have to find how much it comes down. This comes from trigonometry and little string ka idea that length of the string is constant. Then loss in P is gain in kinetic energy, but the velocities are not same. That comes from constraints. Have a look at the steps. This would be an advanced question. Kinematics, NLM, friction, circular, everything will keep coming as a mix. Because as such, work per energy has nothing of its own. It will tell you initial final state, you have to give me information, then I can say something. Clear? Next one. Let's do something little more easy. I know you guys are missing out on friction. Let's bring him. Because the moment you bring friction to the picture, generally energy is not conserved. So any doubts on this? Please ask. Any step you're not convinced, the initial part, how did I get the distance gone down, or how did I get this velocities? Anything? Do make sure to try all these things again. Next one. So we have a rough track here. From A to B. This is 10 meters. And mu is 0.3. This side is smooth. This side is also smooth. Now what you did, you took a block here of mass m and you released from rest here. This height is 10 meters. Now you tell me what do you think will happen. If you leave the block from here, this will start coming down, it will start sliding. Because of friction, it will slow down a bit, then it will go up here, but it won't go to the same height. Then it comes down again, it will again slide, it won't go to the same height, again it will slide and eventually stop. Na? Because of the rough surface on the ground, eventually it will stop. Find the position where the block stops. Options will be 2 meters from A, 3 meters from B, something like that. Let's get this. I hope everyone's getting the scenario because only the AB part is rough. Left and right is smooth. So this will just keep on oscillating, and because of that rough part, eventually it will stop. So where will it stop on the system AB? Where it will stop at AB? 3.33 from B. See. Now, I don't know where it will stop, but let's say it stops somewhere here. This is my state 1. This is my state 2. Potential energy, mg10, or let's call it mgh. Kinetic energy, 0. Potential energy, 0. Kinetic energy, 0, because we came to rest. Now there is a friction here. Work done by friction is not 0. So we know work done by external force is E final, that is E state 2 minus E initial. So this, who is the work done by external force here? The work done by external force is friction only here. So work done by friction is E final 0, E initial is mgh. And what is work done by friction? Minus mu mg into S. So from here we get S is equal to h by mu. What is this S exactly? This S is the distance traveled on the rough surface, isn't it? Think about it. When will friction come? Friction will come only when you're traveling on AB, no? Isn't it? This is the distance traveled on the rough surface, not the total distance. Because when you're here, there is no friction. So work done by friction is 0 here. This S is the distance traveled on rough surface. So this is 10 by 0.3, that is 33.33 meters. So how does this travel 33.33? See, in the first trip, when you go from here, A to B, you will cover 10 meters, great. Then you'll come back again you'll cover 10 meters, great. Then again you'll go third trip, you'll cover 10 meters, but this time when you come back, you cover only 3.33 meters and stop. That is the meaning of this. So the answer is 3.33 meters from B. Is that making sense? The total distance you'll travel on the rough surface is 33.33 meters. So you'll go once 10. I don't count this distance. I only count the distance on the rough surface. Again 10, 20, 30, 33.33. Is that making sense? Anyone confused with this? So the answer is 3.33 meters from B. How is this? Clear? Puruja? Clear? Ansh? Clear, na? Ahana? Arnav? Nikhil? Niharika? Any doubts on this? It's a good question. The standard mains level 1. Next one. If x is equal to t square by 2 plus t power 4 by 4, x is your x coordinate. Mass is 2 kg. Find the work done in 2 seconds. Let's get this. This is another variety of questions. Eighty-four. Okay, we have one answer. Let's see. No, when you get a question like this, think about it. I'm asking you work done. Can you tell me all the formulas that you know about work? Integral f bar dot dr bar. Right. So, okay, fine. So I have an idea here. I can differentiate this 2 times. I'll get acceleration. I'll get force from there. And then I can find dx here and integrate. That is one way. Quite long. Is there any other formula? What is work done by all forces? Change in kinetic energy. That means if I differentiate this, I will get velocity v here. So v is dx by dt. That would be t plus t cube. At t0, v is 0. At t is equal to 2, v is equal to 16. 2 plus 2 cube, 10 meter per second. And I know work done by all forces is change in kinetic energy. Mass is 2 kg, so half into 2 into 10 square minus 0, 100. Is that making sense, everyone? So when you get questions like this, they ask you x coordinate or something or velocity. Indirectly is asking you use work done by all forces change in kinetic energy. You can try with integration, you'll get the same answer, but goes quite long. Check. This is a good one, proper mains level question. Not tough, but this is a question which you can do in a minute, saves you time, gives you marks. Most people will not understand how to do and they will leave it. Clear? Any doubts on this? Last one. U of x is x power 4 by 4 minus x square by 2. This is your potential energy. Mass is 2 kgs. Total energy of the system is 2 joules. Find the maximum speed of the particle. Okay. You have one answer. Root 2, 1.5. You have 2 different answers. P by root 2. See, first thing, what is total energy? Total energy is potential energy plus kinetic energy. So if you want maximum speed, so when potential energy is minimum, kinetic energy is maximum. Why? Because total is constant. Does everyone agree with this? Now, the most common mistake what people do, they think potential energy minimum is 0. That is a mistake what people do. So see, so function u is x power 4 by 4 minus x squared by 2. How do you find the minimum value of a function, maximum minima? Differentiate. Du by dx is x cube minus x equal to 0. Then we get x is equal to plus or minus 1. Double differential, we need to check who is maximum and who is minima. Then we get 3x square minus 1. At x is equal to 1, d square ux square by dx square is 3 minus 1, 2 greater than 0. This is minima. Agreed? So that means when x is equal to 1, you're getting a minima. How much is that? Therefore, u minimum will be 1 by 4 minus half. Minus 1 by 4. This is the minimum value. 0 is not the minimum. Potential energy can become negative also. Remember, because of reference, you can have a negative potential energy. So there, now the total energy is u minimum plus kinetic energy maximum. So this is given as 2. This is minus 1 by 4. This is kinetic energy maximum is half m v max speed square. If you have maximum kinetic energy, you have maximum speed. So this is 9 by 4. Mass is 2 kg. So v max is 3 by 2, 1.5. Most people, what they think the minimum potential energy is 0. Then write half mv square is equal to 2. They get root 2. And unfortunately, that will be there in the option. Potential energy can take a negative value also. So minimum need not be 0. It can be less than that. Is this clear, everyone? It's a pretty good one. There. So have a look at this. We have done some pretty good ones today. Definitely set. Right? Go through the notes once and solve all the problems. We have done almost like 24. The next class, when we catch up, we'll continue from here. We'll bring springs also into the picture now. That will become even more fun. And then after that, we will see. Now we saw some of a circular motion, but then we will see vertical circular motion also. I think we should be able to wrap up in 3 more classes. So we'll do a lot of problems. Next 3 classes, all problems only. So before the Diwali break, we will wrap up the chapter and then we will catch up after the break. Okay, with this, we'll wrap up for the day. So any doubts in class notes, and we will discuss the paper also. So if you have any doubts, anything, stay back, or else you're free to leave.